Okay, so we have worked out AC analysis for simple problems, for relatively simple circuits. We've gone through some examples of that. Complex circuits use all the stuff you learned before. So let's go through that. This is a simple circuit. So I'm going to say we've done something real similar to that. So I'm not going to do that again. You guys get to do that as practice. This is more of that simple circuit. Here's one I want us to take a look at. So we have to compute I0. We have a voltage source and a current source. The book went through, I'm going to go through these kind of quickly. Node analysis. So we have this node right here and this, oops, gotta get a pen up. I don't know why it didn't give me a pen. Okay, V1 divided by these impedances are going to give you this current here. And then we have to add the two currents. This arrow is in the opposite direction of this arrow, so that's where you get the negative sign. It's a super node, created a super node, and so we have two variables, V1 and V2. So that's the current leaving, this right here. This is the current leaving right here. V2 over 1 ohm is the current leaving. It's I naught, by the way, what we're trying to find. And V2 over the sum of these two is the current leaving also. So leaving is positive. Yeah, leaving's all positive. Everything's going out is the way this is looked at. It's identical to what you've done before, what you did for DC analysis. We have a constraint of what the difference in voltage is. I naught, of course I mentioned that, speaking about it. Now, we take that constraint and plug it in to this equation right here. We do a substitution for V1 to get this equation. And from now on, it's just math. Just lots and lots of math. Tedious math. Yeah, I don't even want to do this in new octave. It's going to take a while. They kind of skip from here to here without looking at it closely. So I'm just going to look at it a little closely. 4 times 1 is 4. Minus plus. So j times negative j. First, you know, the FOIL method. First, inner, outer, last. Last would be j times negative j, which is a real number, positive 1. And then the rest of them are complex. So we'll do outer and inner. So outer would be negative 4j, and inner would be 1j. All over 2. So that's 5 halves. The real part's 5 halves. The imaginary part is 3 halves. So I'm convinced now. And then you convert it to an angle. Okay. Uh-oh. Finding my mouse. Okay, now we're going to look at the identical problem using loop analysis. So let's go here. I naught equals I3, so that is here's I3, here's I naught's the one going through the resistor. This would be I2, the big outer loop, I2, for loop analysis. So I1 is going to be the source, and it's negative. I1 is going in opposition to this arrow. It's negative. That's easy. Loop 2 is the big outer one. So the way I think about it is you go up in voltage and then you start dropping. They think about it just the opposite. So they're thinking it's like I have their arrow reversed when I think about problems. But then it converts to the author's way of thinking by just multiplying by a negative sign. So it's just the way I learned it. It's just the way I learned it. The author learned it a little different way. So we have the 1 plus j, this impedance, times I1 plus I2 minus the voltage here, and 1 minus j times I2 plus I3 here for the last one. And then a third loop, which is just this little one alone. Impedance, the sum of the two impedances, times I2 plus I3, and then you just have I3 going through the 1 ohm, and it's the negative of I naught. Okay, so you got to find I3, and they came up with this equation. I'm going to work that out. It looks like they combined these two, and I'm going to work that out and be back with you. I'm going to pause a second. Be back. Okay, here's how this works. I1 is a negative 2. So this equation can be rewritten as 1 plus j times negative 2. 0 degrees would be just a real number, negative 2. Plus I2 plus JI2 minus, let's see, minus 6 plus 1 minus j, or I want to collect terms in terms of I2. So I'm going to go I2 minus JI2 plus, and I3, I'm going to keep the 1 minus j binomial. And all that stuff equals 0. Okay, so we can see where this term comes from. Move to the other side of the equation. The plus 6, just moving it to the other side of the equation. The 2I2, where does that come from? There we go. There's the 2 I2s. And let's see. Ooh. 1 plus j. Here we go. Here's the 1 minus JI3 right there. 1 minus JI3. And JI2 and negative JI2 cancel out. So we can see where they get this equation from. Right down there. Sometimes the book author skips over a little too fast. Let's keep going forward. So then the second equation rearranged. You get 2 equations and 2 unknowns. New Octave or MATLAB would be great to solve this. Yeah, one I3 here, a second I3 here, minus J I3 here. And so this is two equations and two unknowns. They're just going through the two equations and two unknowns. I'm going to set this up in new octave and just see what we come up with there. And we're almost done. Then I naught equals all this stuff. I'm going to flip over to new octave. Okay, so I've set this up in new octave. It works the same way in MATLAB. I set up a matrix equal to the coefficients of I2 and I3, right there. Second equation, 1 minus j, 2 minus j, 1 minus j, 2 minus j. J equals I, by the way. 2 and 1 minus j here, 2 and 1 minus j here, complex numbers. And then what's on the other side? Well, the second vector would be 0, the second element would be 0. The first element, when this is reduced, it becomes 8 plus 2j. And then we simply do, oh, I better get over to new octave. M goes into A. So the equation we're solving is mx equals A. And we're trying to find x. I'll make it x equals. X is going to be a vector which tells us what I2 and I3 are. There we go. And negative I3 is going to be our answer. So it'd be 2.5 minus 1.5 would be I naught. Okay, so that's how to use new octave for this, but also how to go through a problem like this. And I'm going to end here. This may be the last video. The rest of the slides will be examples, will be work examples for you. I think you've seen a couple hard ones.